Good day, everyone. We are Group 5, and in this case study, our main objective is to analyze trends in online learning by examining a dataset of over 50,000 online courses from Coursera. We aim to identify which courses and providers stand out in terms of popularity and ratings. Additionally, we want to understand what features learners value most in online courses. To achieve this, we will explore several key questions. For instance, how can we standardize course ratings and reviews to ensure they are consistent and accurate? We also need to consider the impact of missing data. What happens when important information like skills gained or course reviews is not available? Furthermore, we will investigate how inconsistencies in the names of course providers can affect our analysis and whether there are any courses that are misclassified which we can correct. For our analysis, we are using a dataset sourced from Coursera, which is publicly available and includes data collected from user interactions with courses. This dataset contains several key columns. The course ID is a unique identifier for each course, while the course title is the name of the course. The course partner indicates the organization offering the course, and the course rating reflects the average rating given by users, which helps us gauge the quality of the course. Additionally, Course Review provides written feedback from users about their experiences. The Skill Gain column lists the skills that learners can expect to acquire after completing the course. And Course Detail includes extra information such as duration, level, and certification options. Overall, this dataset includes over 50,000 courses, more than 1,000 course partners, and around 500 unique skills and categorizes courses into 5 levels: beginner, intermediate, advanced, and so on.
For the first part of data preparation, we first import the needed modules and then load the dataset. Then afterwards, we perform the cleaning process by clearing out rows that contain null values or are duplicates. The next thing to do in this process is exploratory data analysis. For this, here's some noteworthy things we did, those being analyzing the 15 most common words within the data of course title using a line graph, counting the number of courses per course partner through a horizontal bar graph, using a parser function to split the data in the course details column into duration, level, and certification, and analyzing the parsed columns to determine most common course durations and distribution between courses and course levels. Before moving on to the modeling process, the data had to be split up through these steps: checking for outliers in the dataset, converting values in the course review, course rating, and duration columns to numerical values, creating a categorical column for course partner, and defining X and Y variables for testing.
To determine which online course features most impact skill gain, such as review count, provider, and duration, we applied a data driven modeling approach. We chose linear regression for its simplicity and interpretability when working with continuous data. Data preprocessing included encoding categorical variables like course providers and transforming text fields into numerical formats. The model showed strong performance, a mean squared error of 6.6809, an R squared score of 1.0, and 100% training accuracy. These results suggest the model can fully explain the variance in learner skill gain from the training data. It sets a solid foundation for course recommendation systems and data driven curriculum design. To better capture nonlinear relationships in the data, we use a decision tree regressor. This model is ideal for handling mixed data types and capturing complex variable interactions that linear regression might miss. It was trained on the same pre-processed dataset, but its tree-based structure allowed it to detect more nuanced patterns. In terms of performance, the decision tree regressor significantly improved results. It achieved a very low MSE of 0.0098, an R-squared score of 1.0, and a training score of 100%. Its strength lies in its ability to split data based on conditions, making it highly effective, especially with categorical fields like course providers.
Now, let's delve into our evaluation results. First, our linear regression model performed best overall. It explained about 71% of the variation in skill gain, had a low mean squared error of 0.0613, and achieved over 80% training accuracy. This shows it fits the data well and makes reliable predictions. Next, we observed that the decision tree regressor showed signs of overfitting. While it reached a very high training accuracy of 94%, its test results were weaker with a lower R squared score and higher error. This means it performed well on known data but struggled to generalize new data. Another important point is that linear regression is highly interpretable. It clearly shows how factors like course reviews, duration, and provider affect skill gain. This insight can help instructors and platform designers make data driven improvements to courses and recommendations. Finally, our evaluation highlights opportunities for future improvement. We recommend using regularization or advanced models like random forests or gradient boosting to prevent overfitting. Adding more features such as learner demographics or engagement levels can also help us make even better predictions.